An ad for a loan promoted an annual interest rate of 6.25%. What is the effective annual yield if it is compounded monthly? And we'll also repeat it for continuously. Now, to do this problem, we've already dealt with effective annual yield. What we haven't done is where we're going to have to actually calculate something for what in the previous one we were given what the final amount is. Now we're going to have to actually calculate it. So just to deal with it, we'll just assume the monthly amount is 1. We could also say that it was a sub 0. It doesn't matter. If it's a sub 0, we'll leave a sub 0 in the problem. And we say we have 1 is our 100% plus 0.0625 divided by 12. Now, why are we dividing by 12? Because we have an annual rate of 6.25, and we're dividing by 12, so that's giving us our rate for that month. And we raise it to the 12, and that's going to be for 1 year, because there's 12 months in a year. And if we do that calculation, we get 1.0643 and ... times a sub 0. Now, remember, when we're looking at effective annual yield, we're going to say, all right, if we have this a sub 0 again, and that's why we could have said that it's 1. We want to say, what would the interest rate be if it was only done once during the year? Or in other words, that this 1.0643 equals 1 plus r. So r is 0.0643, which as a percentage would be 6.43%. If it's continuously, we have a very similar situation, except remember, as soon as you see continuously, what should come to your mind is we're doing it all the time. It's infinite. It takes us to e. So this is e to the rt, and our r value, our rate, is 0.0625, and our t value is just 1, because we're talking about 1 year. And we're going to set that equal to a sub 0 times 1 plus r, and that would be to the first power. We get on this one, we do the calculation, just type it in on your calculator, 1.06449 equals 1 plus r. We're dividing by a sub 0, they go away, so r equals 0.06449, or approximately 6.45%. Notice I'm not rounding until I have converted it to my percent. And again, we've done these problems a couple of ways. We've done it as 1 plus r, we've done it as 1 plus r over 100. It doesn't matter which one you do. At this point, we've looked at some general equations. Y equals a times b to the x. We have p equals p sub 0 e to the rt, or we've seen it as a equals a sub 0 e to the rt. Remember, when we have our sub 0 there, or you'll also hear that called p naught, a naught, that this is a constant. Whereas when we write p, we're talking about the function p of t. And we also have a of t equals a sub 0 1 plus r over k to the kt. What we want to see is that these are all basically the same. We also have our half-life problem. We could say a equals a sub 0 1/2 to the t over k. Now these k's are different k's. What you want to recognize is that they're all really the same equation. We have some constant, and when we're dealing with our word problems, that's our initial amount. We're raising it. We have some multiplication factor. So here we have 100% plus whatever the rate is for that period. Here our multiplication factor was 1/2. Over here it was e, or you could think of it as even e to the r. And then on the original one, it's just b. We raise that to some power. That's in the interest rate. That's the number of times we're compounding it. And the number of times we want to raise it to that power.